11.3. The vertical motion of a mass A is defined by the relation x equals 10 sine of 2t plus 15 cosine of 2t plus 100, where x and t are expressed in mils and seconds respectively. Okay, so first thing to note is that if x is expressed in mils, then that means that this guy has to be in radians, right? Okay. Determine A, the position, velocity, and acceleration of A when t equals 1 second, and the maximum velocity and acceleration of mass A. So this is a problem in which we're given an equation for the position of this guy. It's vertical position, so it's a position along this thing here, and perhaps it's going, so this is our x, and perhaps when it goes downwards, that's going to be positive x, and when it goes upwards, it's going to be a negative x. We can determine that's up to us, but regardless, we know that it's a sine and cosine function, so it's going to be going up and down all the time. And what we need to do is, well, if we have the position function, we just need to derive that one time in respect to time. That's going to give us the velocity function, and if we derive that again, we get the acceleration function. With those, we can plug in t equals 1 second and find what we're looking for part A. So let's start by doing that. So actually, let's start just by plugging in what's x at, let me do it like this, x at t equals, what was it, 1 second? Yeah, 1 second. 1 second, what is that? Well, we have the 10 times sine of 2 times 1, so 2. Oops, 2. Plus 15, the cosine of 2 times 1 again, so 2, plus 100. Okay, we know that's given in mils, and don't forget that this has to be in radians, or else you're going to get wrong answers. This turns out to be x equals 102.85 mils. 102.85. Cool. So now let's go ahead and find an equation that an equation for the velocity. And the velocity is just how x is varying with time. So in other words, if we take the derivative of x in respect to time, and xb is 10 sine of 2t plus 15 cosine of 2t plus 100. So if we take this derivative here in respect to time, we should get the velocity. And we can do that quite easily. Derivative of sine, that's going to be cosine, so it's going to be cosine of 2t. What else? We have the 2 there, so we have to derive the function 2t as well, and that's going to be a 2, so we're going to have an extra 2 there, right? So times 2 plus, we have 15, and then derivative of sine, that's the negative, the cosine is the negative sine, so negative sine of 2t, and same thing again, so we're going to have to derive the function 2t, so that's going to give us another 2 here. What else? And then 100 is a constant, so that comes out as 0. And so the velocity function for this block A turns out to be 20 cosine 2t minus 30 sine of 2t. Okay, that's pretty much it. And now, same thing, we can do the same thing again. So if we want to know what's the velocity at time equals 1 second, then it'll just be v equals 20 cosine of 2 minus 30 sine of 2, again in radians. And this turns out to be minus 36.5-ish. 36 point, double check that, 36.05. Sorry, 0.6. It looks like a 5, but it was a 6. And that's mils per second, right? Because we had the x in mils, so our v is going to be in moles as well, but now we derived in relationship to the time. Time is given in seconds, so that's going to be millimeters per second. Okay, now once again, we can do the same exact thing. So we're going to take the velocity function, and we're going to remember that the acceleration is just how velocity changes with time. So in other words, what we can do is to find the acceleration, we just take the derivative of the velocity in respect to time, and the velocity we happen to know, and that is 20 cosine of 2t minus 30 sine of 2t. Okay, so the acceleration equals 20 derivative of the sine, it's cosine is negative sine of 2t. We have the 2 there, so we're going to have an extra 2 multiplying, and minus 30, and then we have derivative of sine, which is just cosine of 2t, and then we have the 2 again, so another 2 multiplying. So that means that the acceleration for this block A is minus 40 sine of 2t minus 60 cosine of 2t. Cool. And then last part for part A, what is the acceleration when the time is 1 second? So that's straightforward. Acceleration will be minus 40 sine of 2 minus 60 cosine of 2, again radians. It's going to give me negative 0.4 mils per second squared. Okay, so that does it for part A. Let's actually put down the answer. So this is the answer for the acceleration. This is the answer for the velocity. And where's my, there you go. And this is the answer for the position. Okay, what next? What next? B, what is the maximum velocity and acceleration of A? Okay, so we have equations that define the velocity and acceleration at any given point. And we know that they're going to be cyclical functions, right? So regardless if we're thinking about the acceleration or the velocity, what we're going to have in, pretty x-axis here respective. This is time. So we're going to have something that's cyclical, right? It's going to be going up and down like that. And then if we want to know what's the maximum velocity, well, we need to take the derivative of the function we're looking for and make that equal to 0. Because at 0, that's going to be right when on the inflection point, regardless of whether it's on the positive or on the negative side. Just note that if our function looks like that, so let's redraw that. Time here. Let's say that our function looks like this. Okay, so know that it's dislocated downwards in respect to the center of the t. So then our maximum velocity in magnitude is actually going to be this guy here. Because this one here, let's say this is, I don't know, 10 meters per second. So this guy here is probably minus 30 or minus 20. So this is going to be our maximum velocity there. Okay, in magnitude, obviously. And this is valid for both velocity and acceleration. Now, another thing to note, I'll show you that later. So let's just do that one first. So if I want a maximum velocity, what I do is I'll take the velocity equation, I'll derive it in respect to time, and I'll make it equal to 0. Okay, and the derivative of the velocity, we know already that's actually equal to the acceleration, so all I need to do is find where the acceleration equals 0. Okay, so I need to make, where's my acceleration function? So that's going to be minus 40 sine of 2t minus 60 cosine of 2t, and that has to be equal to 0 for me to find the maximum one. And there's a couple ways you can do that. One way is go ahead and simplify this. So I'm going to have, I can remember that the tangent is just the sine over the cosine, right? So what I can do is I can divide everything by 2 cosine of 2t. I'll do that. Just do this, get rid of this. So what I'm going to do is 0 equals minus 40 sine of 2t minus 60 cosine of 2t, and I'll divide everything by the cosine of 2t. Okay, so as long as the cosine is different than 0, I can do that. And we know that that's not going to be always true because at some point cosine is equal to 0. But for the sake of finding the magnitude, it's going to be just fine. Okay, we get rid of that, and then this becomes a tangent. Right, so in other words, I'm going to get minus, let's just keep it consistent, 0 equals minus 40 tangent of 2t minus 60. And therefore, the tangent of 2t equals negative 2/3. So, in other words, 2t equals the inverse tangent of negative 1.5. And don't forget, this has to be rated once again, or else you're going to get something completely off. Okay, and if you do that, obviously there's two values for that. There's two values for the tangent value of negative 1.5. If you remember how this works, we have our y here, we have our x here. It's supposed to be in the middle, it's not, but you get the point. And the tangent is a tangent line. That's what it's called, tangent. It goes over here. Okay, and if we have, for instance, a value here, okay, we have a value here of certain radians, then the tangent is going to be the value of read off of this red bar there, that tangent line there. And if the point is here, for instance, then it's going to be that guy there. And if the point is here, for instance, then it's also going to be that point there. So in our case, we have a value of negative 1.5. We're just going to make up a value here. Let's say that's over here. And it's going to be below the x-axis because it's negative. I don't know exactly where it's going to be. So if that's the case, then I just need to get this point and see where this is going to cross. It's going to give me two values, right? One over here and one over here. So I'm going to get two values out of the arc tangent, right? Doing arc tangent to find what's the arc that corresponds to negative 1.5. And what did I get? I got, so let's actually do this. So minus 1 of negative 1.5. And get two values. Negative 0.9827. So that will be this bottom value here, the negative one. And the other one just obviously just that plus pi, right? So we have 1 pi distance. So just do pi minus 0.9827. Don't forget that this is equal to 2 times time. So the negative value doesn't really mean anything for us physically here, right? So we can discard that one there. So that means that 2, let's change colors. So that means that 2 times my time equals pi minus 0.9827, which means that time, this guy here is approximately 1.0794 seconds. Okay, so in other words, at approximately 1.0794 seconds, my velocity is maximum. That's the time at which my velocity is maximum. Right? We can do the same exact thing for the acceleration, except that for the acceleration we have to derive one more time because we don't really have the derivative of it yet. Right? So let's do that. Remember that acceleration? We had the equation we just used, which was minus 40 sine of 2t. We get minus 40 sine of 2t minus 60. Minus 60 cosine of 2t. That's the equation that we had for the acceleration, right? If we want the maximum acceleration, then we're going to have to derive the acceleration in respect to time and make that equal to 0. So let's first start by deriving the acceleration in respect to time. I'm going to get, so we have minus 40, and then the cosine of 2t. Once again, we have that 2 multiplying, and then we have minus 60, and then we have sine, we have minus sine of 2t, and the 2 again multiplying. Right, so we get the derivative of the acceleration in respect to time is minus 80 cosine of 2t plus 120 sine of 2t. And we're making this equal to 0 to find what is that, the time at which acceleration is maximum, right? So once again, we're going to do the same process. We can divide by the tangent on both sides, cosine of 2t on both sides to get the tangent on this fella here. And we end up with the tangent of 2t equals 80 divided by 120, which is just 2 over 3. And once again, we're doing arctangent. So we're going to get that 2t, do arctangent, then we get 2t equals 0.588 seconds. So that means that t is approximately 0.294 seconds. Okay, so that's the time at which the acceleration is maximum. So what was the question asking? We did all this, I forgot already. It's actually asking us what is the maximum velocity and the maximum acceleration. Okay? So what do we do now? Now that we know the time at which this occurs, what we can do is we can take the equations for them. What is the equation for the velocity? Here it is. And this is the equation for the velocity. This is the equation for the velocity. We can plug in the time at which it occurs, right? And where was the time? There you go. Here you go. Okay, so this is the velocity at any given time, and this is exactly the time at which our velocity is going to be maximum. So that means that my Vmax is just 20 times the cosine of 2 times 1.0794 minus 30 sine of 2 times 1.0794. Maximum velocity is negative 36.1 mils per second. Okay, so that's the answer for the velocity. What about the acceleration? Same thing. Let's just grab the acceleration equation. Where is it? Here it is. We found this time here to be the time for the, this is not our answer yet. We found this one to be the time for the maximum acceleration. So therefore our Vmax will be minus 40 sine of 2 times 0.294 minus 60 cosine 2 times 0.294. So our maximum acceleration is 72.11 mils per second squared. And that is our answer. However, before we tune out, there is one thing that we can note that makes our lives easier. So depending on the situation, if you just want to make this faster, or you can note is the following. Both the acceleration equation, actually highlight that a lot differently, both the acceleration equation and the velocity equation, they are sine and cosine equations, right? So what's happening here, if we look closely, we have these values here that are varying between minus 1 and 1, minus 1 and 1. And they're being amplified by the 40 and the 60. Okay, so that means that our maximum acceleration is actually limited by that. If you think about it, at any given point, again, let me try to draw a circle. I'm not the best drawing circles, or anything for that matter. So if at any point we choose a point there, we're going to have a magnitude that is related to the cosine and a magnitude that's related to the sine. And our acceleration is just going to be the hypotenuse between the two, right? Right there. That's horrible drawing. I apologize. Over there. Okay, so that, if we're talking about velocity, it's going to be velocity. If it's acceleration, it's acceleration. Okay, so in other words, what we can do is we can just apply Pythagoras to this and actually find out what we're looking for. So if we want the maximum velocity, okay, what we do is we take the maximum value that we can obtain on the sine function and the maximum value we can obtain on the cosine function, and we do this. Pythagoras, the hypotenuse squared has to be equal to, what was the values for Vmax for velocity? They were 20 and 30. Okay, so it has to be equal to 20 squared plus 30 squared. So therefore, my Vmax has to be the square root of 20 squared plus 30 squared. So the Vmax is, and then obviously this is going to be, it's going to be positive or negative, but it's going to spit out as positive or negative because it's a square root, so it's 36.1 mils per second. So that's a way to save up time in a way. So as long as you understand what you're doing, that's fine to do that this way. And the acceleration, same thing, right? So the same situation I just drew here applies for the acceleration as well. So the maximum acceleration squared has to be equal to whatever is amplified, the sine and cosine on the 40 and 60. Okay, so the maximum acceleration, it has to be equal to 40 squared plus 60 squared. So therefore, the maximum acceleration is just the square root of 40 squared plus 60 squared. And once again, positive or negative, and this is 72.11, thankfully, exactly the same as the other way of finding it. Okay, so this is another way, tricky, savvy way, let's put it, of finding the maximum velocity and acceleration in situations like this.